Hi everybody, today we're going to do more graphs of sine and cosine function. This will include finding the function graphed. So as a quick reminder, when we have f of x is a times sine of bx minus c plus d, or f of x equals a times cosine of bx minus c plus d, the absolute value of a is the amplitude. It's always positive. D is the vertical transformation. Positive will be up, negative will be down. The period will be 2 pi over the absolute value of b, and then the phase shift will be found by setting bx minus c equal to 0. We're going to start with f of x is negative 4 times the cosine of 8x minus pi over 4 minus 5, and we're going to identify all the little pieces of the function. I'm going to start with the amplitude. The amplitude is going to be 4. Notice it's a positive 4. The negative shows we have a reflection of the function. The vertical transformation comes from the negative 5 at the end, and in this case the function is moving down 5 units. The period is found by taking 2 pi and dividing by 8. We can take 2 pi over 8 and simplify it a little to make it pi over 4. To get the phase shift, we're going to take 8x minus pi over 4, and we're going to set it equal to 0. That says 8x will be pi over 4, which says x is pi over 32. The phase shift of pi over 32 will go to the right because pi over 32 is positive. Let's use Desmos to take a quick look at what the graph of this function will look like. I typed in f of x is negative 4 times the cosine of 8x minus pi over 4 minus 5. You can see the entire function is under the x-axis. That comes from the vertical transformation down 5. Earlier we said the period is pi over 4. To see the 4 pieces of the cosine function, we're going to divide that by 4 again, which will give us pi over 16. So in the settings, I'm going to go to the step for the x-axis and I'm going to put pi over 16. And to zoom in a bit, I'm going to go from 0 to pi over 4 to try to see one full period. This helps us to zoom in a little more and see the function in its entirety. It may help to put in the midline of y equals negative 5. That way we can see the highs and the lows of the graph. You can see it shifted over a little from our phase shift, and we also see the amplitude of 4 reflected in the graph. Now let's try graphing f of x is 3 times the sine of pi x minus 1. We'll start by stating that the amplitude is 3, and we can see that the negative 1 is a vertical shift down 1 unit. This will give us a midline at y equals negative 1. To find the period, we divide 2 pi by the coefficient of x. In this case, we have 2 pi over pi, which is 2. We don't have a phase shift this time. To see the full period, I'm going to take the 2 and divide it by 4. This is going to give me 1/2, so the tick marks on my x-axis are going to be at a distance of 1/2. Now we're ready to plot our points. I'm going to start by putting in my midline, which is y equals negative 1, and I'm going to dash it just for clarity that it's not a real line of our graph. At 0, I'll be at negative 1. Then at my first mark, which is 1/2, I'm going to be 3 above the midline, so 1, 2, 3. At 1, I'll be back to the midline. At 1.5, I will be 3 below the midline. 1, 2, 3. When I get to 2, I'll be on the midline. This shows me I have one full period of the function between 0 and 2. We can connect the dots to see the function. If you wanted to continue the function, you would just repeat this pattern.